Today we are with the snake ladder problem. It has been asked in the Amazon, and I have picked up this problem from the interview bit. It's there in the LeetCode as well. So the rules of this game is that we have a dice and it can have faces from 1 to 6. It is starting from the 1 and landing on the square 100. So like from the one corner you have to go to the another corner and think like a matrix. So I'll show you one image. This is like a snake ladder image. It is a 6 by 6 matrix, but in our problem it is 10 by 10 matrix. So from the 1 I have to reach to the 36. If I consider a matrix of 10 by 10, then I have to reach from 1 to the 100, n by n, like 6 into 6, 10 into 10, like that I have to reach. And other rules are, so you can see here, these are stairs, there is a snake. From the stairs, from the 3 I have to go 16, and if I'm at the 12 I'll come to the 2. The same way we have given the two arrays as a part of the input. So the array A is a stair 1, like 32. From 32 I can go to the 62, or from 42 I can go to the 68, likewise. And this is the snake one, where from the 95, if I'm 95, directly come to 30. It's a downwards. So all the mappings are here, and in the question we are given these two arrays and we have to figure it out. The question is to ask the least number of rolls to reach the destination. So the dices are not given. It's like we have to assume like how many least number of rolls is required for us to reach from 1 to 100. And
Taking a grid of 6 by 6 here, and in the original question is 10 by 10, but just for the simplicity purpose I'm taking 6 by 6. For the stairs is like these are the stairs. So the stairs mapping in the yellow, which I have given the mapping from 3 to 16. We have one stair from 15 to 25 and from 21 to 32. Likewise, we have the mapping for the snakes as well. This is from 12 to 2. So I have marked it like below. So from the 12, I will come to the 2. Now, so whenever something comes like shortest path, the shortest steps, you have to take it, always BFS works. So in the BFS, the general thing, we are always putting the starting point into the queue, taking it out, checking it neighbors, and we are putting the neighbors again back to the queue. So if, and we keep on checking the neighbors, uh, whatever the next neighbors we have inserted based on the visited or the steps, we will do the count. Now, just to illustrate this example itself, um, I have taken the queue. This already have a one. I have a one thing like steps, which is our answer, which is 0 right now because we are already at the first step. So the steps we haven't taken. Now, how we will figure it out what is the neighbors? Okay, for the neighbors, we have the dice like 1 to 6. In the one step, either I can get 1, 2, 3, 4, 5, 6. So if I'm at 1, if I'm getting 1, the next node will be 2. And if I'm getting 2, there will be 3. Likewise, I will get the neighbors of 1. So when this is a queue, when I'm at the 1, I'll take this one out, and I have marked a visited set where I will put this one like visited, already visited. Whenever I'm coming over here again, I will not consider this, which means I will not put it into the queue. Now for the when I am taking the one out, I will check its neighbors. First is 2. I will check 2. It's a part of my stairs or snake. No, there is no mapping available. There is a downwards mapping. So I need not to consider. From where start and goes, I have to consider that. So I will put 2 inside it and the visited array will be 2. Now I have 3. Uh, when the dice is coming to in case 3, then I have a mapping in the stairs, which is 3 to 16. So in the visited array, like 3 have already done it. You do it or not, doesn't matter, but I'm keeping it as of now. And the 16, because the moment I'll come to the 3, I will directly go to the 16. So it's better to check the neighbors of 16 rather than 3, because there's no point checking the neighbors of 3. It's better to check the neighbors for the 16. So I'm putting the 16 into it, and 16 I have marked visited. Now next neighbor is 4 for the 1. Then I will check there is no mapping. I will put the 4 here. I'll put the map into the visited. Likewise 5, yeah, and 6 and 7 are visited here into the uh, queue also. This is like that. Now my head is here, and first of all I have already diced once, so which means my step will become 1 over here. Now till this point, this is first. I will check each and every neighbor, and I will put all the neighbors, all of them into a queue. That will be my second steps. So what I mean, suppose the dice, I'm at the first, and when I roll the dice 1, I am at the 2. Now this is a one time dice has been rolled. Now again I'm rolling my dice. That is the second step, and I will get 3, 4, 5, 6, 7, 8. I will check 3 is there in the visited. Yes, I will not add it. 4 is there. Yes. 5 is there. Yes. 6 is there. Yes. 7 is there. Yes. 8 is not there. I'll put 8. Okay. What if the roll is giving me 2 and I'm at the third one? Then in that case what will happen? I have a 16. So because the 16 I will reach, I will check the neighbors of 16 now. So 16 neighbors will be 15, sorry, 17, 18, 19, 20, 21, 22. So those elements will go into that one. So this is coming as a part of second dice roll. What if this come, what happen? If this come, what happen? Like that. So whenever I'm putting all the neighbors to this range, it will go to the queue, and the steps will become 2, that is plus 1 again. So this is how, and the moment I reach to the 36, I will check if my q value which I'm popping out is equals to n by n, here 6 by 6, then I will return the number of steps. So I will get to know how many times I have rolled my dice. I will explain it more in the coding part.
So we have the two array A and B, and converting these array into the maps. So I am directly pasting the code over here. So it's simple, like from to 2 I'm doing it and making a 2-star map. The uses of this, if I have to figure it out, if this like 1, 2, 3, 4, any of the steps is there into the star map or the snake map, then map is easy, like it's a O1 time complexity instead of the array. Okay, what else is required is the queue. I'm adding 1 into the queue because I'm at the first tab. Visited also. Okay, now I have to make one more thing. Visited array. Sorry, it's not an array, it's a set. I just needed to check it is there or not. Okay, and I need the steps, the dice. I think I will write the dice count. Right now it's 0 because I'm at the 1. So this is the while. In the while loop, I will check if my queue is not empty, then I keep on processing. Otherwise, I will return -1. Okay, here I will check the size of my queue, which is 1 initially because I'm at the first place. How many elements are there in the queue? I will take the neighbors of it. So I'm iterating one by one. So I'm writing it like old, not old well is fine. Q dot poll, and the end, if this value is equals to 100, we are having a 10 by 10, so this is like 100. If any of the q value is having 100, which means we reach to the destination, and we return the steps or dice count. Yes, and if not, then we will pop out, as we have already poll one element, and we gonna check the neighbors. So this is J, starting from the dice, starting from the 1 to 6. So this is how it will, and I will get the new value, which is value plus J. So roll, the dice will roll 1, 2, 3, 4, 5, 6, and we will check for each and everything. Once we have this, any new value is coming. So if you see the example we have taken it, we are the 1, we are going to the 2. I will check first of all if it is a part of my visited set or not. This new value, the 2, is there or not. If it is not there, then only I will do some operation, otherwise I will pass on. I need not to add it because it's already been added into the queue. Now here I will check star map dot contains key, and this key is new val. If any star is going from this particular node, so 1 plus 1 2, from the 2, if any node is going or not, I'll do some comparison. Okay, else if I will check it, the snake, if the new value we have checked it, is anything going from there, any snake is there. If nothing is there, then we simply add it into the queue. And end of this if else if, here anyways, once we have checked those visitors, calculate those visitors, we have to add into our set. Okay, now what will, now on the star map, if I'm finding something on the star which is 3, like 3 to 16 we are going, so in that case I'm adding 16, which the value I'll get 16 from the map, the star map, because I'm matching with that only. And for the visited one, I will add this new value. 3 is already been added here, so I'm adding the from to, this is the from part has already been added, now I'm adding the to part. So I'm just using the example I have shown you before, so it will be easy, like 3 to 16 why I'm doing this. Same thing will happen for the snake array. So if I'm finding anything that the snake map, I will add into the queue and I will add into the visited one. Now let me run. Okay, so okay, whenever I'm doing this for loop, after that I have to increase my dice count. So the thing is, whenever how many elements are there, like as you should have the 1, I'm at the 1 and I'm adding 2 3 4 5 6, this is the 1 dice I'm playing. So once I'm done with that, I have to increment my count. Okay, that was a silly mistake, and this is the correct answer. I'm submitting this and I pass this.